We are starting with atoms and elements as our first unit. So some basics. Atoms are made up of subatomic particles. So what does that mean? It's made up of protons, neutrons, and electrons. Protons have a mass of 1 AMU and have a 1+ charge, a positive charge. Its location is in the nucleus along with the neutron. A neutron is considered neutral, so it has a 0 charge, and it has a mass of 1 AMU as well. We also have electrons as a subatomic particle. Those hang out in the electron cloud, or the levels and orbitals. You'll kind of hear us using those words interchangeably. They have the equivalent to 0 AMUs, and it has a negative charge.
AMU is the unit that we use to measure teeny tiny things, because the atom and its subatomic particles are very small. So AMU stands for atomic mass unit. And as you can see, the proton and the neutron are basically 1 AMU each. And so they are going to be what the atom consists of in terms of its mass. So when we talk a little bit later today about mass number and the mass of particular atoms, it is the combination of protons and neutrons that are going to provide us with that. And as Ms. Case just told you, the electrons basically don't have any mass. Right? They're just very fast moving, tiny negative particles, excuse me, that are floating around the nucleus itself. Note that word subatomic. We'll be asking you a question shortly about what that means. So think of that word breakdown as well.
All right, so our atomic structure looks like this. So in the middle there, we have our nucleus, where you can find your protons and your neutrons. Protons are normally, sometimes you'll see them with that plus on there, so that you know those are the protons. And then the neutrons, because they are a neutral charge, won't have anything. Then you have the electrons whizzing around the outside. They go quickly, like Ms. Laporte said, and those are normally indicated with a negative inside that circle, so that you know that those are the electrons, or that negative charge.
And we will be taking you through some diagramming during class time, so that we can get a feel for putting together these atoms and how they are structured. You can see the traditional old school orbital design. Basically, this is the easier to draw design compared to the picture here on the left, where you can see these orbitals kind of overlapping each other and sideways and on different planes. That's a little bit more realistic to what electrons are doing inside of the nucleus. And this link here, let's see if it works up, good. This is how we'll be building some atoms in class. And you can do this on your own, because you just saw us link it from the PowerPoint, the Google Slides. And you can make some changes to protons, neutrons, and electrons. All right, so you can change these numbers. And then you'll be able to build, and then you can toss them in the trash in order to do that as well. So that's a good way to be able to practice proton, neutron, and electron number. Now I got to do my fancy flipperoo, so Ms. Case can continue talking.
So the atomic structure. So we need to remember that the atom is the smallest particle of an element, and it still retains the properties of that element. And then our other reminder is that the nucleus of an atom is the most dense part of that atom, and it contains almost all of that atom's mass. Remember, our protons and our neutrons make up 1 AMU, so each. So that's where all of our mass is coming from, is from those numbers. Our electrons, remember, are pretty much equivalent to 0, or closest to 0. So there's not as much hanging around and whizzing around on the outside of that nucleus.
Correct. And note the stuff that is underlined on these slides. This would be good stuff in your notes to highlight in a different color, or to do like a fill color behind it, or change the font color, or bold it, as those are key pieces of information. And you will see throughout, we will either have things bolded, underlined, or color coded to draw your attention to key facts, key pieces of information, key concepts throughout any of our notes. And those would be good things to highlight and make note of.
All right. So as we just said that the most dense part is in the nucleus, you have to also remember that most of the atom, though, is empty space. So although the dense space is right there in that middle in the nucleus where the protons and the neutrons are at, the atom itself has a lot of empty space.
Just think about it. You have the heaviest parts of the atom condensed and packed into the center, all right, all the way in that center, and they are jam-packed, and that's something we'll learn about as we go through this semester and we talk more about atomic and nuclear structures. So they're packed in there very, very tight, and they're held together by a very, very strong force that holds them there. Our electrons are tiny and practically massless and are just zipping around, as you can see here, flying around that nucleus. And they're only hanging out around that nucleus because they have an opposite charge to the protons. Right? We know opposites attract. It's something we'll talk a lot about and sing about later this semester. That those electrons are going to be attracted to the protons, and that's why they hang out. That's why they stay. But between that teeny tiny electron and that dense tiny nucleus in the center, all the rest of this, there's nothing there. All right? That's pure empty space. So that's an important concept to remember because it'll explain a lot of the reasons why atoms are going to bond and interact and perform the chemical reactions that they do.
All right, so what atomic characteristics is unique to each element? The number of protons is what is unique to each individual element. It determines the element, and we kind of reference it as like an ID card, a social security number, your ID here at school. Nobody else has that number except for you as far as your ID goes. Same goes for an element. The number of protons an element has tells us which element we are working with. So if you take a look at the bottom left-hand picture there, we've got the mass number of 4, the number of the atomic number on the bottom left there. That number 2 is the number of protons. The atomic number is equal to the number of protons. So anytime you are looking at number of protons and it's 2, you automatically know it will be helium, which is that element symbol there on the right, which says He. Same goes, go ahead.
Just saying, make sure to highlight, we got it color coded here. So just drawing your attention, as best case finishes, drawing your attention to that number of protons. That is your key identifier for every single element. No two elements have the same atomic number, the same number of protons.
And then for the picture on the bottom right, we have carbon, and our number of protons for that is 6. It's the same as its atomic number. So anytime you see the number 6 for number of protons, it will equate to carbon. Okay. So when comparing elements using the periodic table, this is a very important slide, and I would probably put a highlight or somehow box it or highlight this information. This is important. So we've got our atomic number. The atomic number is equal to the number of protons, which we just talked about in that last slide. The chemical symbol, it's the abbreviation for that element's name. So it's always going to have an uppercase as that first letter. And if there is a second letter or letters after that, they will all be in lowercase. The atomic mass is the average mass of all the isotopes of that element. So that's what the atomic mass is. That's not something that we will be using. We'll be using the mass number. So that is a whole number always. And it's the number of protons plus the number of neutrons. Remember, our protons and our neutrons are both in the nucleus. That's our densest part. So that's going to make up our mass number.
So again, you can see a couple of things color-coded in different color. I know my little exit thing keeps popping up at the bottom, so I'm trying not to move it. But that mass number equation is something that you need to memorize. You need to know that so that when you are looking at what we'll call PNE charts, proton, neutron, and electron charts, when you are given information about a unknown or mystery element, like its proton number and its electron number, or its neutron number and its proton number, you are able to determine what element it is and calculate its mass number. Again, as Ms. Case pointed out, the atomic mass or the average atomic mass is almost always going to be a decimal number, and that's the number you'll find on the periodic table, but we're hardly ever going to use it other than to simply know what it is on the periodic table. We will always be working with that mass number. So mass numbers are whole numbers. All right, so no decimals, no fractions. They have to be a whole number. Why? Look at your equation. P plus N equals mass number. There's not a fraction of a proton or a fraction of a neutron or a decimal of either one. You either have one proton or you have two protons. You don't have 1.75 protons. Same for neutrons. So your mass number will always be a whole number. Good additional note to write down in your notes or type in your notes. And the atomic mass or the average atomic mass will almost always be a decimal. And so we know that's not the number we are going to be using.
All right, and this is a picture of our periodic table. You should have this in your Google Drive in our classroom folder. Please make sure that you have that in there. I would probably put your name on it instead of it probably saying copy of, or it might already have it on there. We will be taking a look a little bit more in depth of this on Wednesday.
So just a couple of things in terms of this copy. You'll have your own copy to work with and practice with. On any assessments, you will be using this periodic table. So I'm about to show you an interactive periodic table that Ms. Case also has linked on the Google site. And that's fun to use and good to use because it provides you with a lot of information, and obviously it's interactive, so it can, be used in a variety of circumstances. But this is the periodic table at which you're going to be gathering information or utilizing in our class. Again, here is that key for the elements, providing you with the name, the atomic number, aka the proton number, the chemical symbol, that average atomic mass that we're not going to be using, that is a decimal, and then the electronegativity, which is another number we are not going to be concerned about. If you go on to take chemistry, you'll be concerned about those two numbers. Okay. Let me click on this really quick before we wrap up. Scientific American with your ads. All right. And then you can see the interactive periodic table here. So you have some color coding here. You have every single element. Let's do a little sodium. It's always our go-to. Get rid of these cookies out of my way. All right. And so there's sodium. So it's going to provide you with some fun facts. It's going to give you the phase it normally exists at and some other categories. And then it'll provide you possibly with an article with a little bit more information. So we may be directing you back to this link later on in this unit or in future units to be able to interact and find out a little bit more information about some of the elements that we will be working with in this chemistry portion of our semester.